Hello students, welcome to your channel Parivartan Physics. See, in this video we'll learn a practical called as velocity of sound using resonance tube or resonance column, right? So this is the instrument which we are going to use in this practical called as resonance tube. Dear students, if you are new to this channel, please don't forget to subscribe the channel and please share the video, share the channel with your friends. And please go through the channel once, go through the playlists, find the playlist and see the videos in the playlist. You will find number of videos which are helpful for your preparation of NEET CET as well as board examinations as well as practical examinations, right? So it will be surely helpful for you. Please go through the channel once and daimadi channel na video na share madlikke maribadri. Please share with your friends as well as with your juniors, right? And please speak about the channel with your classmates. Thank you so much for watching this video, and let us begin the video now. We'll start the practical in detail about velocity of sound using the resonance tube. Okay. Okay, so this is the instrument we are going to use in this practical. It is called as resonance column or resonance tube, right? So we'll see in detail about this resonance column now, right? So have a look of this first. Okay, see here, ಇಲ್ಲಿ ನಮಗೆ steel pipe ಕಾಣಿಸ್ತದಲ್ಲ, the steel pipe is called resonance column. ಈ steel pipe ನಾವು resonance column ಅಂತ ಕರಿತೀವಿ, resonance tube. And here we have a meter scale. ಇಲ್ಲಿ ನಮಗೆ meter scale ಅದ ರೀ, right? This is the meter scale. Okay, ಇಲ್ಲಿ ನೋಡ್ರಿ, this is the water reservoir. ಅಂದ್ರೆ ನಾವು ನೀರನ್ನು ಇಲ್ಲಿ ಹಾಕಬೇಕು. We have to put the water here. This is the water reservoir. So ಈ ಗ್ಲಾಸ್ ಒಳಗೆ ನೀವು ಹಾಕಿದ ನೀರು ಏನಾಗ್ತದಪ್ಪ ಅಂತಂದ್ರೆ through this transparent tube, ಈ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಟ್ಯೂಬ್ ಥ್ರೂ ಹೋಗಿ ನಮಗೆ ನೀರು ಏನಾಗ್ತದಪ್ಪ ಅಂದ್ರೆ ಇನ್ ದೀಸ್ ಬೋತ್ ಟ್ಯೂಬ್ಸ್ ಇಟ್ ವಿಲ್ ಗೆಟ್ ಸ್ಟೋರ್. ನೋಡ್ರಿ, ಈ ಸ್ಟೀಲ್ ಏನ್ ನಮಗೆ ರೆಸೊನೆನ್ಸ್ ಕಾಲಮ್ ಅದಲ್ಲ, ಇದ್ರೊಳಗೂ ಕೂಡ ನೀರು ಹೋಗ್ತದ್ರಿ. ಆಮೇಲೆ ಈ ಸ್ಟೀಲ್ ರೆಸೊನೆನ್ಸ್ ಟ್ಯೂಬ್ ಬಾಜುಕ ಇಲ್ಲಿ ನಿಮಗೆ ಮತ್ತೊಂದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಟ್ಯೂಬ್ ಕಾಣಿಸ್ತದ್ರಿ, ರೈಟ್? ದೇರ್ ಇಸ್ ಒನ್ ಮೋರ್ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಟ್ಯೂಬ್, ರೈಟ್? ಯು ಕ್ಯಾನ್ ಸಿ ದ ಕನೆಕ್ಷನ್ ಇಸ್ ಲೈಕ್ ದಿಸ್. ಈ ವೈರ್ ನಮಗಿಲ್ಲ, ಇದೇ ನಮಗೆ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಟ್ಯೂಬ್ ಅದಲ್ಲ, ಇಟ್ ಹ್ಯಾಸ್ ಬೀನ್ ಕನೆಕ್ಟೆಡ್ ಫಾರ್ ಬೋತ್ ದ ಟ್ಯೂಬ್ಸ್, ಫಾರ್ ಸ್ಟೀಲ್ resonance column as well as for this transparent glass tube. Okay, what is the use of this? ಈಗ ನೋಡ್ರಿ, ನಮಗೆ ಏನ್ ಬೇಕಾಗಿರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ we want to find the resonance resonating length here. ಈ ಪ್ರಾಕ್ಟಿಕಲ್ ಒಳಗೆ ನಮಗೆ resonating length ಫೈಂಡ್ ಮಾಡಬೇಕಾಗಿರ್ತದೆ. ಈಗ ನಮಗೆ ಈ ಸ್ಟೀಲ್ ಪೈಪ್ ಒಳಗೆ ನೀರಿನ ಲೆವೆಲ್ ಎಷ್ಟದ ಅಂತ ನಾವು ಫೈಂಡ್ ಮಾಡ್ಕೋಬೇಕಾಗಿರ್ತದೆ. What is the level of water in this steel pipe? That is what we want to find. So how to know ಇದ್ರೊಳಗೆ ನಮಗೆ ನೀರು ಎಲ್ಲದ ಅಂತ ಕಾಣಿಸಂಗಿಲ್ಲ, whether it is up till this point or this point ಅಥವಾ this point. We can't see that, right? ಅದು ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಇಲ್ಲ. ಸೊ ಇದ್ರೊಳಗೆ ನೀರಿನ ಲೆವೆಲ್ ನೋಡ್ಕೊಳಿಕ್ ಅಂತೇಳಿ ಈ ನಮಗೆ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಗ್ಲಾಸ್ ಟ್ಯೂಬ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ, ರೈಟ್? ಸೊ ಈ ಟ್ರಾನ್ಸ್ಪರೆಂಟ್ ಟ್ಯೂಬ್ ಒಳಗೆ ನಿಮಗೆ ನೀರಿನ ಲೆವೆಲ್ ಇಲ್ಲಿ ಕಾಣಿಸ್ತದ್ರಿ. ಯು ಕ್ಯಾನ್ ಅಬ್ಸರ್ವ್ ಇಟ್ ಹಿಯರ್. ಸೊ ಅಪ್ ಟಿಲ್ ದಿಸ್ ಪಾಯಿಂಟ್ ದ ವಾಟರ್ ಇಸ್ ದೇರ್. ಸಿ ಹಿಯರ್ ಯು ಕ್ಯಾನ್ ಚೆಕ್. ಅಪ್ ಟಿಲ್ ದಿಸ್ ಪಾಯಿಂಟ್ ದ ವಾಟರ್ ಇಸ್ ದೇರ್, ರೈಟ್? ಸೊ ಇಲ್ಲಿವರೆಗೂ ನಮಗೆ ನೀರು ಅದಾವ್ರಿ. ಸೊ ಈ ಟ್ಯೂಬ್ ಒಳಗೆ ಎಲ್ಲಿ ತನಕ ನಿಮಗೆ ನೀರು ಕಾಣಿಸ್ತಾವಲ್ಲ, ಈ ಟ್ಯೂಬ್ ಒಳಗೂ ಕೂಡ ಅಲ್ಲಿವರೆಗೂ ಮಾತ್ರ ನೀರು ಇರ್ತಾವ್ರಿ. ಸೊ ದ ವಾಟರ್ ಲೆವೆಲ್ ಇನ್ ದಿಸ್ ಟ್ಯೂಬ್ ಇಸ್ ಅಪ್ ಟಿಲ್ ದಿಸ್, ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ ಟು ಸಿ ದ ವಾಟರ್ ಲೆವೆಲ್ ಇನ್ ದ ಸ್ಟೀಲ್ ಪೈಪ್, right? So we can see the water level exactly and we can also take the reading now. So ಈಗ air column ಅಂತಂದ್ರೆ ನೋಡ್ರಿ, ಈಗ ಇಲ್ಲಿವರೆಗೂ ನಮಗೆ ನೀರು ಅದಾವ್ರಿ, right? Up till this point the water is there in this steel tube. So this much is the air column now. ಇಷ್ಟು ನಮಗೆ air column ಅದ. This much is the air column. ಇಲ್ಲಿ ಇಷ್ಟು ನಮಗೆ ನೀರಿಲ್ಲ, air ಅದ. So ಇಲ್ಲಿವರೆಗೂ ನೀರು ಅದಾವ್ರಿ. So what is the length of the air column then? ಇಲ್ಲಿ ನಾವು length of the air column ನೋಡ್ಕೋಬಹುದು, 18 centimeter ಅದ ರೀ, right? So 18 centimeter is the length of the air column ಅಂತಂದ್ರಿ, right? So that is how we have to see the reading in this experiment, right? Okay, now let us go for the next step then. Okay, along with that we are going to use two tuning forks here. This is the tuning fork. See, first tuning fork is of frequency 384 hertz, and one more tuning fork we are going to use, it is of frequency 426 hertz, right? So these are the two tuning forks we are going to use in this practical. Okay, now let us go step by step to the procedure of this practical. We'll continue. Okay, so this is the chart we are going to follow in this practical. See, the name of the practical is velocity of sound. We are going to determine the velocity of sound at room temperature using resonance tube. This is the aim of the practical. As I have told you in all the practicals, aim, apparatus ಮತ್ತು procedure. There is no need of writing these things in your practical examination. You should start from principle, right? So we are going to determine the velocity of sound in air at room temperature using resonance tube. So the principle of the practical is principle of resonance. ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನಾಗ್ತಿರ್ತದಪ್ಪ ಅಂತಂದ್ರೆ, see, this is an air column. ಈ ತರ resonance tube ಇರ್ತದ ನಮಗೆ. This is the resonance tube, correct? Okay, one end of the tube will be closed. ಒನ್ ಎಂಡ್ ನಮಗೆ ಕ್ಲೋಸ್ಡ್ ಇರ್ತದ್ರಿ. ಈಗ ಇದ್ರೊಳಗೆ ನಾವು ಏನ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀವಪ್ಪ ಅಂತಂದ್ರೆ ವಿಲ್ fill up the water. ಇಲ್ಲ ನಾವು ನೀರು ತುಂಬಿಕೊಂಡಿರ್ತೀವಿ. ಕರೆಕ್ಟ್, we fill up the water. Next, we take a tuning fork and we hit the tuning fork to a rubber pad. Rubber pad hit ಮಾಡಿ ಈ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ನಮಗೆ ವೈಬ್ರೇಟ್ ಆಗ್ಲಿಕ್ಕೆ ಶುರು ಆಗ್ತದೆ. This tuning fork starts vibrating with its own natural frequency. So the waves, sound waves created by the tuning fork will go in this tube. Waves ನಮಗೆ ಈ ತರ ಟ್ಯೂಬ್ ಒಳಗೆ ಹೋಗ್ತಾವ್ರಿ. They will go inside this. They will hit the surface of water and they will come back. Water surface hit ಆಗಿ they will come back. Right? So ಈಗ ರೆಸೊನೆನ್ಸ್ ಆಯ್ತು ಅಂತ ಯಾವಾಗ ಹೇಳ್ಬೇಕ? See, ಇಲ್ಲೇ ನಮ್ಗೆ ಇಷ್ಟು ಏನು ಪಾರ್ಟ್ ಅದಲ್ಲ, this part of the column is called air column. ಯಾಕಂದ್ರೆ ಅಲ್ಲಿ ನಮಗೆ ಏರ್ ಅದ. This is called air column. Right? Air column. And this is filled with water. So this is not called air column. ಇದು ನಮಗೆ ಏರ್ ಕಾಲಮ್ ಅದ್ರಿ. ಒಂದ್ ಎಂಡ್ ನಮಗೆ ಏರ್ ಕಾಲಮ್ ಅದು ಕ್ಲೋಸ್ಡ್ ಅದ, ಇನ್ನೊಂದು ಎಂಡ್ ನಮಗೆ ಓಪನ್ ಅದ್ರಿ. ಸೊ ದಿಸ್ ಇಸ್ ಓಪನ್ ಟ್ಯೂಬ್ ಅಂತ ನಾವು ಕರಿತೀವಿ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಓಪನ್ ಆರ್ಗನ್, ಓಪನ್ ಟ್ಯೂಬ್. So when this when this tuning fork starts vibrating and the waves travel in this air column ನಮಗೆ ವೈಬ್ರೇಟ್ ಆಗ್ತಿರ್ಬೇಕಾದ್ರೆ ಈ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಎಷ್ಟಿರ್ತದಲ್ಲ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್, if the frequency of tuning fork and the frequency of the waves created here, frequency of the air column, the frequency, if these both frequencies become equal, then you will hear a loud sound. ಒಂದು ದೊಡ್ಡ ಸೌಂಡ್ ನಿಮಗೆ ಕೇಳಿಸಿದ್ರಿ ಯಾವಾಗ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಮತ್ತು ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ ದ ಏರ್ ಕಾಲಮ್ ಎರಡೂ ಈಕ್ವಲ್ ಆದಾಗ ಒಂದು ಲೌಡ್ ಸೌಂಡ್ ನಿಮಗೆ ಕೇಳಿಸಿದ್ರಿ. ದಟ್ ಇಸ್ ಕಾಲ್ಡ್ ರೆಸೊನೆನ್ಸ್. Then we can say it has resonance is occurred. Right? That is the principle of this experiment. The air column in the resonance tube vibrates with maximum amplitude when the frequency of air column is equal to the frequency of the tuning fork. ಅಂದ್ರೆ air column ದ frequency ಮತ್ತು tuning fork ದ frequency ಯಾವಾಗ ಈಕ್ವಲ್ ಆಗ್ತವೆ ಅವಾಗ ನಮಗೆ ಏನಾಗ್ತದ್ರಿ, ರೆಸೊನೆನ್ಸ್ ಆಗ್ತದೆ. Right? This is the principle. Okay, what is the formula? Velocity of sound in air at room temperature is given by V is equal to 2F L2 minus F1, L2 minus L1. What is F? Frequency of the tuning fork. L1 first resonating length, L2 second resonating length. ನೋಡ್ರಿ, ಒಂದೇ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ನಿಮಗೆ ಎರಡು ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ಸ್ ಸಿಗ್ತಾವ್ರಿ. ರೈಟ್? ಸೊ ದೇರ್ ವಿಲ್ ಬಿ ಟೂ ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ಸ್, ಫಸ್ಟ್ ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ ಅಂಡ್ ಸೆಕೆಂಡ್ ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ ಅಂದ್ರೆ ಎರಡು ಡಿಫರೆಂಟ್ ಪೊಸಿಷನ್ಸ್ ಒಳಗೆ ಎರಡು ಡಿಫರೆಂಟ್ ಲೆಂತ್ ನಿಮ್ಗೆ ರೆಸೋನೆನ್ಸ್ ಆಕರ್ ಆಗ್ತದೆ. ಸೊ ದೋಸ್ resonating lengths are called first resonating length and second resonating length. Right? That is the principle and formula of this experiment. See, this is the diagram of the instrument which we are going to use. Ille now mainly ಏನೇನ್ ತಿಳ್ಕೊಬೇಕಂತಂದ್ರೆ this is the resonance tube. ಇದು ನಮಗೆ resonance tube. Here the waves are coming. Here the waves are striking the surface of water. Right? ಇಲ್ಲಿ ನಮಗೆ air column ಅದ. This is the air column. Correct? Okay, this is the tuning fork. ಇಲ್ಲಿ ಒಂದು ಮೀಟರ್ ಸ್ಕೇಲ್ ಯೂಸ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಇದು ವಾಟರ್ ರಿಸರ್ವೇರ್ ಅದ. ಆಸ್ ಯು ಮೂವ್ ದಿಸ್ ಅಪ್ ಅಂಡ್ ಡೌನ್, ಇದನ್ನ ಮೇಲ್ಗಡೆ ಕೆಳಗಡೆ ಮೂವ್ಮೆಂಟ್ ಮಾಡಿದಂಗ ಇದೇನ್ ನಮಗೆ ಟ್ಯೂಬ್ ಒಳಗೆ ನೀರಿನ ಲೆವೆಲ್ ಅದಲ್ಲ, ದಿಸ್ ವಾಟರ್ ಲೆವೆಲ್ ವಿಲ್ ರೈಸ್ ಅಂಡ್ ಫಾಲ್ ಆಸ್ ವಿ ಮೇಕ್ ದ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ದಿಸ್. ಈ ರಿಸರ್ವೇರ್ ನಾವು ಕೆಳಗಡೆ ತಗೊಂಡು ಹೋದಂಗ ಇದ್ರೊಳಗಿಂದ ವಾಟರ್ ಲೆವೆಲ್ ಕೂಡ ಕೆಳಗಡೆ ಬರ್ತದ್ರಿ. ಈ ರಿಸರ್ವೇರ್ ನ ಮೇಲ್ಗಡೆ ತಗೊಂಡು ಹೋದಂಗ ಇದ್ರೊಳಗಿಂದ ವಾಟರ್ ಲೆವೆಲ್ ಕೂಡ ಮೇಲ್ಗಡೆ ಬರ್ತದ್ರಿ. ಸೊ ಟು ವೆರಿ ದ ಲೆವೆಲ್ ಆಫ್ ವಾಟರ್ ಇನ್ ದಿಸ್ ರೆಸೋನೆನ್ಸ್ ಟ್ಯೂಬ್ ವಿ ಯೂಸ್ ದಿಸ್ ರಿಸರ್ವೇರ್. ಈ ರಿಸರ್ವೇರ್ ನಮಗೆ ಮೂವೇಬಲ್ ಇರ್ತದ್ರಿ. ದಿಸ್ ಇಸ್ ಮೂವೇಬಲ್, ಇದು ಫಿಕ್ಸ್ಡ್ ಅದ. Right? So reading ನೋಡ್ಕೊಳ್ಳಿಕ್ಕೆ, ಲೆಂತ್ ನೋಡ್ಕೊಳ್ಳಿಕ್ಕೆ ನಮಗೆ ಮೀಟರ್ ಸ್ಕೇಲ್ ಅದ. So this is the instrument which we use. Right? Okay. So that's all about the instrument, principle, formula and apparatus. Next, we'll see the observations and tabular column. Right? See, observations notary, laboratory temperature. So presently the laboratory temperature here is 28 degrees Celsius. 28 degrees Celsius is the laboratory temperature here. ನೆಕ್ಸ್ಟ್ ಇದು ನಮಗೆ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗದೆ. ನೀವು ಆಸ್ ಇಟ್ ಇಸ್ ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಒಳಗೆ ಇಟ್ಟರೆ ಏನು ತೊಂದರೆ ಇಲ್ಲ. ಕೆಲ್ವಿನ್ ಒಳಗೆ ಬೇಕಾದ್ರೂ ನೀವು ಕನ್ವರ್ಟ್ ಮಾಡಿ ಇಡ್ಬೋದು. ಹೌ ಟು ಕನ್ವರ್ಟ್ ಟು ಕೆಲ್ವಿನ್? 28 ಡಿಗ್ರಿ ಸೆಲ್ಸಿಯಸ್ ಪ್ಲಸ್ 273. ಸೊ ದಿಸ್ ವಿಲ್ ಬಿ 301 ಕೆಲ್ವಿನ್. ಇಷ್ಟು ನಮಗೆ ಕೆಲ್ವಿನ್ ಒಳಗೆ ಆಗ್ತದ್ರಿ. ಓಕೆ, ಈಗ ನೋಡ್ರಿ ಪ್ರೊಸೀಜರ್ ಏನದಪ್ಪ ಅಂತಂದ್ರೆ, ಸಿ ದ ಪ್ರೊಸೀಜರ್ ಇಸ್, ಸಿ ನೀವೆಲ್ಲೇ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ತಗೊಂಡು ಇಫ್ ಯು ಸೆಟ್ ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಇನ್ ದ ವೈಬ್ರೇಷನ್ ಅಂಡ್ ಇಫ್ ಯು ಹೋಲ್ಡ್ ಇಟ್ ಹಿಯರ್, let me say at this length, ಈ ಲೆಂತ್ ನಮಗೆ ಒಂದು ದೊಡ್ಡ ಸೌಂಡ್ ಕೇಳಿಸ್ತದೆ, ಲೌಡ್ ಸೌಂಡ್. ಇಫ್ ಯು ಹಿಯರ್, then we can say the resonance has occurred. So you have to measure this length. ಈ ನೋಡ್ರಿ, ಇಲ್ಲಿಗೆ ನಮಗೆ ರೆಸೋನೆನ್ಸ್ ಆಕರ್ ಆಗಿತ್ತಪ್ಪ ಅಂತಂದ್ರೆ this length we have to take. ಈ ಲೆಂತ್ ನಾವು ತಗೋಬೇಕು. ರೈಟ್? ಸೊ ದಿಸ್ ಇಸ್ 10, 15, 16, 17. ಸೊ ಇಲ್ಲಿ 17 ನಮಗೆ ರೆಸೋನೆನ್ಸ್ ಬಂತು ಅಂತ ಇಟ್ಕೊಡ್ರಿ. ಸೊ ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್. ಈ ತರ ಒಂದು ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ನಮಗೆ ಎರಡು ರೆಸೋನೇಟಿಂಗ್ ಲೆಂತ್ ಬರ್ತಾರೆ. ಒಂದು ಇಲ್ಲಿ ಬರಬಹುದು, ಒಂದು ಇಲ್ಲೇ ನಮಗೆ ಬರಬಹುದು. So two resonating lengths we will get. So here what we have to do is, see, frequency of tuning fork, first tuning fork ನೀವು ಏನು ತಗೋತೀರಿ ಆ tuning fork frequency ಬರೀಬೇಕು. First resonating length L1, second resonating length L2. So for same tuning fork we will get two resonating lengths. ಅವು ಎರಡು ಇಲ್ಲಿ ಬರ್ಕೋಬೇಕು, L1 and L2. Next, you change the what tuning fork, the frequency will be changed. Frequency change ಮಾಡಿದ್ಮೇಲೆ ಅಥವಾ tuning fork change ಮಾಡಿದ್ಮೇಲೆ you should again take two resonating lengths. ಮತ್ತೆ ಎರಡು resonating length ಗಳನ್ನು ನೀವು ತಗೋಬೇಕು, L1, L2. After that, you have to calculate the velocity of the sound, right? Okay, so that is all about the observation and observation table. We'll go for the procedure now. We'll see the instrument, we'll take the readings L1, L2, and we'll come back to this table again, okay? Okay, now you can observe the water level is exactly here. ಈಗ ನಿಮಗೆ ಇಲ್ಲಿ water level ನೀವು ನೋಡಬಹುದು, this is the water level. So water level is at 30.5, okay, 30.5 or 30.8, somewhere there it is, close to 31 it is, right? So this is the water level. So now what I will do, I will take a tuning fork and I will hit it and I will hold it here on the top of the resonating column and will listen the sound. If the sound is maximum, then okay. If sound is not maximum, then we'll again lowerize this water level. This water level now mat 1 by 1 centimeter, 1 centimeter, 1 centimeter now ಕೆಳಗಡೆ ತಗೊಂಡು ಹೋಗಬೇಕು, and then we have to check whether the sound is loud or no. Okay, we'll continue then. Okay, now we'll understand the complete procedure first. We'll see the complete procedure and then we'll go step by step for this practical. See here, we are going to use two tuning forks. One is of 384 hertz and another one is of 426 hertz. Right? So, ಈಗ ನಾವಿಲ್ಲಿ ಏನು ಫೈಂಡ್ ಮಾಡಬೇಕಾಗಿತ್ತು ಅಂದ್ರೆ we want to find out the resonating length. Resonating length ಅಂದ್ರೆ ಏನು? Resonating length ಅಂದ್ರೆ it is the length of the air column. Air column means ಖಾಲಿ ಪೈಪ್ ಏನಿರ್ತದಲ್ಲ, ಕೆಳಗಡೆ ನೀರು ಇರ್ತಾವ್ರಿ, ಖಾಲಿ ಪೈಪ್ ಏನಿರ್ತದಲ್ಲ, ಖಾಲಿ ಪೈಪ್ ಲೆಂತ್ ಎಷ್ಟದ, that is resonating length. That is what we want to find. So ಈಗ ಫಸ್ಟ್ ಇದು ಏನು ನಮಗೆ 384 hertz tuning fork ಅದಲ್ಲ, for this tuning fork you will find the resonating length somewhere around 20 and 60. ರೈಟ್? ಸೊ ಈ 20 ಕಿಂತ ಮೊದಲು ಒಂದು 2-3 ಸೆಂಟಿಮೀಟರ್, 20 ಆದ್ಮೇಲೆ ಒಂದು 2-3 ಸೆಂಟಿಮೀಟರ್ ನೀವು ಟ್ರೈ ಮಾಡಿ ನೋಡಬೇಕು. ಸೊ ಅರೌಂಡ್ 20 and 60, two resonating lengths we will get. For every tuning fork you will get two resonating lengths. So for 384 hertz you will get the resonating length somewhere around 20 and 60. ಸೊ 20 ಕಿಂತ ಮುಂಚೆ ಒಂದು 2-3 ಸೆಂಟಿಮೀಟರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ, ಆಮೇಲೆ 60 ಕಿಂತ ಮುಂಚೆ ಒಂದು 2-3 ಸೆಂಟಿಮೀಟರ್ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ. So that you will find somewhere there only in the surrounding of that. So that is for 384. If you are using another tuning fork, then the resonating lengths will be different. That you have to try and see. ನೀವು ಟ್ರೈ ಮಾಡಿ ನೋಡ್ಬೇಕು. ಒಂದು 2 ಸೆಂಟಿಮೀಟರ್ ನೀವು ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ, somewhere ಒಂದು 10-15 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಒಂದು 2-3 ಸೆಂಟಿಮೀಟರ್ ನೀವು ಮೂವ್ಮೆಂಟ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ, you will find the sound. So where you find the sound, there you start moving with a slight distance. ಈಗ ನಿಮಗೆ ಎಲ್ಲೋ ಒಂದ್ ಕಡೆ ಸೌಂಡ್ ಕೇಳಿಸ್ತಪ್ಪ, ಅಲ್ಲಿಂದ ಏನ್ ಮಾಡ್ರಿ, 1 ಸೆಂಟಿಮೀಟರ್ ಮಾತ್ರ ಇನ್ಕ್ರೀಸ್ ಅಥವಾ ಡಿಕ್ರೀಸ್ ಮಾಡ್ರಿ. ಚೆಕ್ ವೆದರ್ ದ ಸೌಂಡ್ ಇಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಆರ್ ಡಿಕ್ರೀಸಿಂಗ್. If you are increasing the length of the air column and if the sound is increasing, you go on increasing. And if the sound decreases, then you have to again decrease the length of the air column. So like that you have to take the variations. Okay. So for 384 hertz, somewhere it will be in the surrounding of 20 centimeter L1. First resonating length will be somewhere around 20 centimeter and second resonating length will be somewhere around 60 centimeter. Right? This is for first tuning fork. Similarly, for second tuning fork, it will be somewhere surrounding of 15 and 55. ಇದರ ಸರೌಂಡಿಂಗ್ ಒಳಗೆ ನಮಗೆ ಎಲ್ಲಾದರೂ ಇರ್ತದೆ. Start from 15 and 55 for 426 hertz. For 384 hertz, you start from 20 and 60. 20 ದಿಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ರಿ, ಒಂದೊಂದು ಸೆಂಟಿಮೀಟರ್ ನೀವು ಇನ್ಕ್ರೀಸ್ ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. ಆಮೇಲೆ ಫಾರ್ L1 you will get, L2 ನೀವು ಏನ್ ಮಾಡ್ರಿ, you start from 60, ಒಂದೊಂದು ಸೆಂಟಿಮೀಟರ್ ಹೆಚ್ಚು ಮಾಡ್ಕೊಂತ ಹೋಗ್ರಿ. Right? Okay. So what we have to do is, so first we have to keep the air column, I mean the water level at 20. ಈಗ ನಾವು ವಾಟರ್ ಲೆವೆಲ್ ಏನ್ ಮಾಡ್ತೀನಿ, 20 ಸೆಂಟಿಮೀಟರ್ ಇಟ್ಕೊಂತೀನಿ. After keeping at 20 centimeter, I will hit the tuning fork, I will set it into the vibration. You can hear the sound here only, I will show you. Like this, the light sound you will hear. Okay, this is the sound of vibration of the tuning fork. It is not the sound of the resonance column. So ಈಗ ನೀವು ಈ ತರ ಇದನ್ನ ವೈಬ್ರೇಷನ್ ಒಳಗೆ ಸೆಟ್ ಮಾಡಿ, you should hold this above the pipe like this. ಈ ರೆಸೊನೆಂಟ್ ಕಾಲಮ್ ಏನದಲ್ಲ, ರೆಸೊನೆನ್ಸ್ ಕಾಲಮ್, ಆ ಕಾಲಮ್ ಮೇಲ್ಗಡೆ ಈ ತರ ಅಥವಾ ನೀವು ಈ ತರ ಹಿಡ್ಕೊಂಡ್ರೆ ನಡೀತದ್ರಿ. ಯು ಶುಡ್ ಹೋಲ್ಡ್ ಇಟ್ ಲೈಕ್ ದಿಸ್ ಅಂಡ್ ಹಿಯರ್ ವೆದರ್ ಯು ವಿಲ್ ಹಿಯರ್ ದ ಸೌಂಡ್ ಆರ್ ನೋ. ಇಫ್ ದ ಸೌಂಡ್ ಇಸ್ ನಾಟ್ ಆಡಿಬಲ್, increase the height by 1 more centimeter. 20 you take it for 21. Again for 21 you check it. If you hear the sound, then it is okay. If you hear a loud sound, then it is okay. If you hear a slight sound, again you increase the height. And the 21 you take it for 22. For 22 also you check it. For 23 also you check it. You will hear a loud sound at one particular distance, at one particular length of the resonance column. That if you hear a loud sound, then that length of the resonant air column is called resonating length. You should note down that. Adha ನೀವು note down ಮಾಡ್ಕೋಬೇಕು. This is first resonating length, L1 for 384 hertz. Similarly, again lowerize the water level for 60 and you started from 60 and go on checking for every 1 centimeter, 61, 62, 63. Somewhere you will find the loud sound and again you note down the resonating length. So this is the L2 for same tuning fork. L2 resonating length for same tuning fork. Same thing you have to repeat for one more tuning fork, that is of 426 hertz. For 426 hertz, you start from 45 and 55, right? That is what we want to do, right? Okay, we'll have a closer look and we'll go through the procedure now. We'll see step by step, okay? Now we just check the water level. Where is the water level here? Water level is here. See, ಇಲ್ಲಿ ನಮಗೆ ಎರಡು ಸ್ಕೇಲ್ಸ್ ಅದಾವ್ರೆ. We are having two scales here. You have to refer this scale. 0 ದಿಂದ ಏನು ಸ್ಟಾರ್ಟ್ ಆಗಿತ್ತಲ್ಲ, 0 ದಿಂದ you have to refer this scale. ಈ ಸ್ಕೇಲ್ ನೀವು ರೆಫರ್ ಮಾಡಿ, right? So water is here now. Presently the water is here. So what is the water level now? Water level is somewhere ಇದು 15 ಅದ, ಇದು 16 ಅದ. So somewhere it is 15.7 or 15.8. Somewhere here it is. Water level ನಮಗೆ ಇಷ್ಟ ಅದ, right? So 15.8, somewhere there it is. That is the water level in this pipe. So ಇದ್ರೊಳಗೆ ಏನು ವಾಟರ್ ಲೆವೆಲ್ ಇರ್ತದಲ್ಲ, ಇಷ್ಟ ನೀರಿನ ಲೆವೆಲ್ ಇದ್ರೊಳಗೂ ಇರ್ತದ್ರಿ. ಸೇಮ್ ವಾಟರ್ ಲೆವೆಲ್ ವಿಲ್ ಬಿ ಇನ್ ದಿಸ್ ಟ್ಯೂಬ್ ಆಲ್ಸೋ, ಕರೆಕ್ಟ್? ಸೊ ಈಗ ನಾವು 384 hertz ದ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ಯೂಸ್ ಮಾಡತ್ತೀವಿ. ಸೊ ವಾಟ್ ಐ ಹ್ಯಾವ್ ಟೋಲ್ಡ್ ಯು, ಫ್ರಮ್ ವೇರ್ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟಾರ್ಟ್ ಇಟ್? ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟಾರ್ಟ್ ಇಟ್ ಫ್ರಮ್ 20. Now it is near to close to 16. 16 ಕ್ಕೆ ಸಮೀಪ ಒಳಗದರಿ. The water level is close to 16. We have to lowerize it to 20. We have to lowerize it to 20. We have to bring it here and then we have to go on checking for every 1 centimeter, right? Okay, we will lowerize the water level now. Okay, see where is the water level? I will show you very clearly now. So water level is near to 16 now, 15.8 ಅಥವಾ 16 ಸಮೀಪದೊಳಗದರಿ. Okay, you have to loosen the screw. ಈ screw loose ಮಾಡ್ರಿ and then go on taking the glass slowly downwards. ನೋಡ್ರಿ, ಗ್ಲಾಸ್ ನೀವು ಕೆಳಗಡೆ ಮೂವ್ ಮಾಡಿದಂಗ water level is decreasing. You can find it there. Water level is decreasing. So where I want to keep the water level? I want to keep it at 20, right? So 20 ಬಂದ ಕೂಡಲೇ ಅದನ್ನ 20 ಸಮೀಪ ಬಂದ ಕೂಡಲೇ you move slowly. Okay, now it is at 20. Clear? Okay, so it is at 20 now. Fine. Okay, ಸ್ವಲ್ಪ ಮೇಲ್ಗಡೆ ಹೋಯ್ತು. It will not suddenly stop as you move the glass. So slowly, ಈಗ ನಮಗೆ ಇದು exactly ಎಲ್ಲಿಗದರಿ? At 20 centimeter it is there. Right? Okay, so the water level is at 20 centimeter now. We are referring this scale. So it is at 20 centimeter now. Clear? Okay, now we'll check whether we'll hear the sound or not. Okay, see now the water level is at 20 centimeter, right? It is at 20 centimeter. And the height of the air column ನಮಗೆ ಎಷ್ಟದರಿ? 20 centimeter. ಅಂದ್ರೆ ಪೈಪ್ ಇಲ್ಲಿವರೆಗೂ ಖಾಲಿ ಅದ 20 centimeter ವರೆಗೂ. From here water is filled. So the height of the air column or the length of the air column is 20 centimeter. Now what we have to do, we have to set this tuning fork in the vibration and we have to check the sound. See, I will tell you this, I will show you this. Right, I guess the sound is audible for you. Okay, I will show you once more. See, ಈಗ ನಮಗೆ ಟ್ಯೂನಿಂಗ್ ಫೋರ್ಕ್ ದು ಸೌಂಡ್ ಕೇಳಿಸ್ತಿರ್ತದೆ. If you set this in vibration, ಅದ್ರದ್ದು ನಿಮಗೆ ಸೌಂಡ್ ಕೇಳಿಸ್ತಿರ್ತೈತ್ರಿ. ಇಲ್ಲಿ ಹಿಡ್ಕೊಂಡಾಗ ನಿಮಗೆ ಸೌಂಡ್ ಬೇರೆ ಕೇಳಿಸ್ತದೆ. Right, I will show you that. I guess the sound is audible for you, but it is not completely loud now, right? So we'll again lowerize the level of water by 1 centimeter again. So I will lowerize the water by 1 centimeter and then we will check again whether the sound has increased or it has decreased, right? Okay, so I have lowerized the water by 1 centimeter and now we will again check the sound. See, yes, so this time the sound is louder. Clear? Okay, otherwise if you want you can check one more again for 1 more centimeter. If the sound increases then it is fine. If sound decreases you have to take it as resonating length only, right? Okay, so I have again decreased the water level by 1 centimeter. It is at 22 now, right? Now 20 check ಮಾಡ್ಕೊಂಡ್ವಿ, 21 check ಮಾಡ್ಕೊಂಡ್ವಿ. Now we are checking for 22. Okay, sound ನಮಗೆ reduce ಆಯ್ತ್ರಿ. Sound is less now compared to 21, right? So we'll again keep it at 21 only. We'll again keep it at 21 or just less than 21. So we'll see whether the sound will be louder or no. Okay, I have kept the water level at 21.5. Okay, let us hear the sound again. Yes, so the sound is maximum now. See, 20 check ಮಾಡಿದ್ವಿ, 21 check ಮಾಡಿದ್ವಿ, 22 check ಮಾಡಿದ್ವಿ. 20 ಗೆ ಲೈಟ್ ಆಗಿತ್ತೆ, 22 ಗೆ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತ್ರಿ. ಸಾರಿ, 21 ಗೆ ಇನ್ಕ್ರೀಸ್ ಆಯ್ತು, 22 ಗೆ ಡಿಕ್ರೀಸ್ ಆಯ್ತು. ಸೊ 22 ಗೆ ಡಿಕ್ರೀಸ್ ಆಗಿರೋದ್ರಿಂದ ವಿ ಕೇಮ್ ಬ್ಯಾಕ್ ಅಗೇನ್. Now 21.5 ಬಂದಿವಿ. At 21.5 it is maximum. See, you can hear it once more. Right? So like this, the loud sound we have to hear, and now you check the distance or the length of the air column. I will show it here. See, what is the water level now? You can check it. What is the water level? See, here is the water level. So this is the water level. What is the length? It is 21.5. So this is the first resonating length, 21.5 for 384 hertz. Okay. Okay, we got the resonating length as 21.5. So this is L1, resonating length L1. Next we have to get one more resonating length, that is L2. I have told you for resonating length L2 you should start it from 60th centimeter, right? So ಈಗ ನಮಗೆ 21.5 ಅದರಿ. This is the water level now. We have to lowerize this. ಈ water level ನಾವು ಕಡಿಮೆ ಮಾಡಬೇಕು. ಎಲ್ಲಿವರೆಗೂ ಕಡಿಮೆ ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ we should get it up till 60 now. So 60th centimeter ನಾವು ಆ water level ತಗೊಂಡು ಹೋಗಬೇಕು. So let us keep it at 60 now. So I will show you the 60 on the scale here. Right? Okay, so that is 60. Okay, so I will lowerize the water level. You can just check when the water will come there. We want to keep the water at 60. Right? Here is the 60. Here is 60. So I am lowering it. So you can check water level is coming here. So at 60 we want to keep it. Fine. So this is 60. So it is at 60 now. I guess you can observe it clearly, right? So it is at 60. Okay, let me show you a little bit more closely. Okay, so this is the water level. It is at 60. So we have to go on checking it for 60, 61, 62, 63, like this. We have to go on checking. I will show you that now. At 61, 62, 63, go on increasing. If you hear the sound at some distance, you take it as resonating length. Okay. Okay, we are taking L2 for 384 hertz. So it is at 60 now. The water level is at 60 centimeter. We'll check the sound. Okay, the sound is very slow. So what we have to do? We have to increase the water level now. I mean, we have to we have to lowerize the water level. So it is at 60. I will decrease the water level now. Okay, let me decrease the water level. Decrease it slowly when you are very down. So I will keep it at 62 because at 60 it is very low. Sound bhal kammi adri 60 centimeter. Bhala kammi iddag ಏನು ಮಾಡಬೇಕ್ರಿ? You can you can decrease the water level by 2 centimeters like that. So I will keep it at 62 now. 60 gitte na ಈಗ 62 kitkontinri. I will keep it at 62. Correct? Okay, now it is at 62. Let us check the sound again. Let us check the sound again. Okay, sound is not again audible. So I will again lowerize the water level. So ಈಗ ನಾ 62 ಇಟ್ಕೊಂಡಿದ್ದೆ. Will take it for 64 now. I will take it for 64 because the sound is very low. So I'm taking it for 64 now. Correct? Okay, so I kept it at 64 now. So let us listen the sound. See. Okay, a little bit of sound is audible now. Correct? Okay, so we'll again lowerize the water level. Since the sound is now little bit more audible, we'll increase the distance by 1 centimeter. It's enough. Right? So I'm keeping the water level at 65 now. Okay, the water level is at 65. Let us hear the sound. Yes, the sound is more, right? Okay, the sound has increased. So somewhere 0.5 centimeter up or down, we'll find the resonating length now. So we'll take little bit more. So I kept it at 65.5 now, 65.5. Okay, we'll check the sound. Yes, the sound is very loud now. Yes, so yes, it is very loud. So now we can say the resonance has occurred. So how much is the air column now? It is 65.5 centimeter. Clear? Okay. So we'll go for the next trial now. That is for 426 hertz. Okay, next trial is for 426 hertz tuning fork. So I told you start 426 hertz around 15 centimeter and 55 centimeter. Since I am coming from down, I am keeping it first at 55 centimeter now. You can watch it here. So the water level is at 55 centimeter, right? Okay, so from here I will go on increasing by 1 centimeter and we'll check the sound. Okay, so the water level is 55 centimeter. It is at 55 centimeter. Let us check the sound. Okay, sound is there, but it is low. Right, it is very low. So what I will do, I will again increase the length by 1 centimeter, or since the sound is very low, I will increase it by 2 centimeter. It is at 55, I will keep it at 57 now. Okay, let us, so you should take the glass downwards, water level will fall, it will decrease. So I am keeping it at 57 now, right? I am keeping it at 57, the water level is 57. Okay, at 57, let us check it. So at 57, the sound has increased. Yes, the sound has increased, but still it is not maximum. That's why we have to again increase. So it is at 57. I will increase it by 1 centimeter. I will keep it at 58 now. Okay, let me keep it at 58. So at 58, we'll check it again. Sound has increased. Yes, it has increased. We'll see 0.5 centimeter more again. So you can 58.5 I will keep it at 58.5. Okay, so this is at 58.5 now. So let us check the sound. See. Yes, now the sound is maximum. Yes, the sound is maximum. So this is the resonating length L2 because we are coming from down top. Right, so this is resonating length L2. L2 is 58.5. So for L1, what I have told you, for L1 you have to keep the water level at 15 and you have to start it. So I will take the glass upside. At 15 centimeter, I will keep the water level. At 15 centimeter, here is the 15 centimeter. So at 15 centimeter, I will keep the water level and will again check the sound level now. Okay, this is at 15 centimeter, or let me keep it at 16. 15 surrounding the new to go rest. Okay, so I have kept it at 16 now. So let us check the sound. Okay, at 16 centimeter. Sound is very low. Sound is very low. So increase it by 2 centimeter. If sound is high, you can increase it by 1 centimeter. I will increase it by 2 centimeter. I will keep it at 18 now. Right, 16 I will keep it at 18. Okay, we'll check it. Sorry. Okay, sound is there. We can find still more sound. So that's why I will increase the distance or length by 0.5 centimeter. Okay, I will keep it at 18.5. 18.5. We'll check it again. Yes. So now the sound is maximum. I guess it is audible for you. Yes. So sharp resonance has occurred. Hence, the resonating length L1 is, let me tell you, L1 is 18.5, right? So the L1 is 18.5 for 426 hertz, correct? So we have taken all the trials. Now we'll move for the observation table and we'll make the calculations. Okay. Okay, so we have gone through the experiment. See, observation we had already written. 28 degrees Celsius was the laboratory temperature. Which was the first tuning fork we had used? We had used the first tuning fork of 384 hertz. 384 hertz. And which was the second tuning fork we used? It was 426 hertz. L1 and L2 now calculate markondidive. See, L1 for 384 hertz. L1 was 21.5 centimeter. 21.5 centimeter. Okay, so L1 was 21.5 centimeter and L2 was 65.5 centimeter. And for 426, no, 384 now first 21.5 centimeter, amele water level lower markondwe, we went in downward direction. Here we got L1 and here we got L2, right? So idu namaga 21.5, 65.5. And while taking for 426, we came in reverse direction. E direction taka ನಾವು ಬಂದ್ವಿ. L1 first ನಾವು L2 ತಗೊಂಡಿದ್ದೇವೆ. First L2 ತಗೊಂಡಿದ್ವಿ, ಆಮೇಲೆ L1 measure ಮಾಡ್ಕೊಂಡಿದ್ವಿ. So L2 was 58.5 centimeter for us, and L1 was 18.5 centimeter. 18.5 centimeter, right? So we got the values of L1 and L2. Now let us calculate the values of value of velocity of sound. See, frequency ಅಂತೂ ನಮಗೆ 384 hertz ಅದ. L2 minus L1. So we'll make the calculations. See, calculations ನೀವು ಇಲ್ಲಿ ನೋಡ್ರಿ detail ಆಗಿ calculation ಮಾಡ್ಬೇಕು. First one, for the first trial, V is equal to 2F into the bracket L2 minus L1. So 2 into 384, 2 into 384 into L2 minus L1. How much is L2? 65.5. 65.5 minus L1, 21.5. So it is 44. 44. So you multiply all this, 44 into 384 into 2. So how much you will get? You will get it as 33792 into 10 to the power minus 2 anta na tagotini. Why? Because this is in centimeter. 44 centimeter, 44 ಏನದಲ್ಲ ಇದು ನಮಗೆ ಸೆಂಟಿಮೀಟರ್ ಒಳಗದೆ. This is in centimeter. So ಅದನ್ನ ಮೀಟರ್ ಒಳಗೆ ನಾ ಈ ತರ ಬರ್ಕೋತೀನಿ. Correct? Okay. So we got this much. Next, if you remove this 10 into 10 to the power minus 2, I will get it as 337.92. Like this I will get it. So this is in meter per second. Centimeter per second it is 33792. This is in centimeter. Correct? So calculate the second one then. Second one calculate madri. V is equal to 2F into the bracket L2 minus L1. You calculate this. 2 into 426. Frequency is 426 for the second trial. Right? So L2 minus L1. So L2 is 58.5. 58.5 minus L1 is 18.5. Right? So it is 40. It is 40. So 40 into 426 into 40 into 426 into 2. Right? So this is 34080. Right? Okay. This is centimeter per second. In meter per second, it will be 3480 into 10 to the power minus 2 meter per second. Or we can write it as 340.80 meter per second. Right? In centimeter per second, I will write it as 3480. Correct? So next, we have to write the result now. Okay, we'll go for the result. See, result ನಮಗೆ centimeter per second as well as meter per second ಎರಡು ತಗೊಳಗೆ ನಾವು ಬರೀಬೇಕು. So centimeter per second ಒಳಗೆ ನಮಗೆ result ಎಷ್ಟು ಆಗ್ತದ್ರಿ? These are in centimeter per second. Right? You have to take the mean of this. ಇವೆರಡು ತರದ mean calculate ಮಾಡ್ರಿ. Right? So what is the mean? See, 3480 plus 33792. Right? So this will be this much divided by 2. You will get it as 33936. Right? So the mean is 33936. So 33936 centimeter per second. Meter ಒಳಗಾದ್ರೆ ಇದನ್ನ ನೀವು 33936 into 10 to the power minus 2 meter per second, or you can simply write it as 339.36 meter per second. So this much will be the velocity of the sound. 339.36 meter per second is the velocity of the sound in air. Right? So that's all about this practical. Dear students, if you like the content of this channel, please don't forget to subscribe the channel and share the channel. Please speak about the channel in front of your friends. Spread the awareness of this channel. Please share the videos as well as channel with your friends. Thank you so much for watching and supporting the channel. Please keep watching and supporting the channel. We'll meet in the next video again. Thank you.